Okay, so tomorrow is your programming test number 0, right? All the materials are there. Please double check the guide. I'll send you guys maybe a quick reminder, maybe later today. Just remind you about the critical rules. And the markup test material is also there. Let me just show you very quickly. You definitely want to be as efficient for other kind of stuff. You know, don't want to waste too much time on certain stuff. I'll show to you. On the lectures page, you will see that under exercises, you can see practice test 0 instruction. That's a markup test. If you click on that, so the PDF is going to be more or less, I would say almost the same. The document you're going to see for all the programming tests. So you can just skim through just about the programming requirements. And also, of course, make sure you submit as many times as you can to back up your work. And there are 2 links you definitely want to pay attention to during the test. So one is under getting started, there will be a here, right here. So you're going to download the starter projects to actually import into Eclipse. That's the first step you want to make sure you do. You can definitely practice that, under the remote lab. Just make sure you know exactly how to do it. The second link is around the end, under submission. Right? You can see under here, you can see there's a link right here. Right? If you click on that, that one they will link you to the web submit. Right? So just make sure these 2 links are very familiar to you, and you want to really also get yourself familiar with importing, exporting the project right during the test. You definitely don't want to waste any time. I think myself or the TAs may be able to help you, during the test, but you don't want to assume that we're going to do it timely, right? So you want to make sure you really don't waste any time yourself. Okay, so that's about the markup test. So I believe you guys will be 1 p.m., right? So just make sure, please wait outside before the test, and then we'll let you in time. So you wouldn't waste any time in the beginning. So machines will get rebooted, and then you can definitely get started. And please make sure you bring a photo ID, right? It is so important. We're going to check attendance very carefully. So please do that, okay? And your lab number 1 is not really covered by programming test 0, but it will be due next Tuesday. So please make sure you actually start in time and also get enough struggle, and of course, can reach out to the TA or myself. And lab number 1 will be covered in programming test 1. So for your programming test 1, tentatively, I'm going to host some review session to really go over with you some practice tests, which I'll also release a little bit later. So I think for all the subsequent programming tests, we'll try to maybe host some review session, also to help you get prepared, and also for written tests as well, to give you as much help as possible. I'll reach out to you. So, all right, guys, any questions? Yeah, go ahead.
Will the programming test be as long as the lab, or just
you can think about the programming test itself is going to be somewhere in between the practice test and the actual lab, somewhere in between. Yeah.
So the lab is too long.
I know, understandable. So I think, I know that you guys got 80 minutes. We'll see how that goes. So I think programming test 0 will give you like an idea about how the subsequent programming test will be like. Yeah. Okay, no worries. Oh, guys, well, I want to give you one tip, which let me just finish the tip, and then I'll give to you. You may want to hear that too, right? So, which I also gave to your fellow student in section B. You may want to look into the code example that we talk about in the slides, specifically static variables, right? So remember, I kind of show you like a project, like an example code for static variables. You may want to look into it. And also, I'm going to go over today about how you can use the static variable to really manage the account ID. That's something you also want to try. Maybe you can extend your lab number 0 by implementing it by yourself. Make sure you can do that. All right? Yes, question?
Is the practice test, like programming test 0, because it's pretty much identical to the lab 0.
That's correct.
At one point you use the method string.contains, but in the guide for it, the only string that's allowed is the format.
Yes, I know what you mean. So in the test you're going to have tomorrow, I don't think you will need to use a contains method. So you can either use the equals method or the format method in the string class. And also please make sure you get yourself familiar about how to use the format, especially how do you print, for example, 1 digit after the decimal or 2 digits after decimal. So these are the common things you want to get used to. Yeah, question?
How many classes will be in the test?
Maybe let me not reveal that, you will see tomorrow.
Okay.
Okay. I would say definitely more than 1.
And also, what is the difference between contains and equals?
Contains is like as part of the string, right? So for example, let's say you have a string Jackie. Does Jackie string contains JA? It does. However, if you say equal, it got to be exactly equal to that particular string.
Does it check for like a substring?
I mean for equals? Contains, in some ways, more like a substring, yes. Yeah, but the substring returns to you back another string. But contains is like a Boolean, either true or false, right? Also play with it, right, with the method, okay? All right, so today we're gonna finish the OOP review. So I'm gonna go with the same pace as yesterday for your Section B fellow students. I'm gonna talk about two things. One will be the static variable. We're gonna do that in the first half. And for the second half, we'll do some more advanced use of the this keyword by using some example. I think both will be beneficial for you to also review. And starting from Thursday, we'll do exceptions. Okay? There will be one or two small topics which we wouldn't get a time to really talk about them in the lecture. So please also review them. It's going to be also beneficial for you for programming test and for written test. Okay? Quick recap from last time. So last time we basically talked about how to trace this particular example there. We got arrays and also we got reference type. Just make sure you can do this kind of tracing. And again, I will highly recommend try to print out the clean page and then try to do it by yourself. I think this kind of exercise will be very, very important for you to do, for example, written test when you actually maybe ask some question about tracing. And we talk about this example here, just about copying the array. Right? So when you say an array is assigned to another thing, so just make sure you understand what it really means, right? You're just copying the address of an array rather than elements of the array, right? Something like that. Right? And you can look at the table to see exactly how the Boolean expressions will change their values. And about aliasing type, aliasing path. So given a particular object, you want to see how many incoming arrows you have to really determine how many paths you actually have, right? So these paths store the same address, so the address of the same objects. Right? And then we talk about the motivating problem for using a variable. So in this case, we don't really have the mechanism for static type. So here we only got non-static type. So that's going to force us to really create some explicit parameter as part of the constructor. That's going to force any user of the account constructor to really pass unique IDs right here, 1 and 1, for example. If you actually pass something that's duplicated, you don't really get any compilation error. That's the issue, right? So you're going to run into some logical error, which we kind of explained last time. And today we're going to see how to do this properly. And that's something I will also recommend you guys try to reproduce by yourself. It's not too difficult, right? You can easily extend your lab 0 or any code example you're working on by using this. So this page just talk about the difference between non-static and also static variables, right? So non-static is going to be a copy for each object. Versus, if you got static, it's going to be a unique copy that's shared by all the objects of that particular class, right? So that's really the critical difference. And today, we're going to see, first of all, how to use the static and non-static to really manage the ID properly. And then I'm going to show you another interesting example. I can tell you that in that example there, we try to use static variable in a wrong way. And we're going to see exactly how to find out what's wrong. Okay. And that's from last time. All right, any questions about static versus non-static? We good? Yes?
How long can you access an increment globally while it's not static from counter to if can I access increment global here if it's not static in general? So instead of the counter g plus 1, can I say counter dot increment global, or do I have to do it static?
I see what you mean. So over here, I think it's a good question. Your fellow student question was, you're talking about, let's say for this one here, right? This method here, okay? So this method here, you can see, can use this method here intends to really update G, which is static. Can you actually call this method here as, let's say, counter dot increment global, okay? The answer is no, I don't think you can, because the method here is not static. So if you want to call some non-static method, you have to create some context objects. Okay, that's why. Okay, so let's now move on to the correct way of using static and non-static. Okay, let's now take a look at this one here. So there are two things you want to notice right away, syntactically. Okay, so we basically got a static integer, I call it global counter, and we still got our non-static ID. All right, so these are the two things. We got to see exactly how to use them. So let me just annotate them very quickly for you. So you can think about this one here is something that's global. And the other one there is going to be local to every object. And this one here is non-static. And this one here is local. Okay? Another thing to note is, you can see now the parameter list for the constructor here has only owner. It does not have the ID anymore. Let me remind you, if you look at what we said last time, right here, you can see as part of the parameter list for constructor account, we have the ID. But now in the correct version, we don't have ID anymore. Okay, so that means if you want to call the constructor for the account, you don't have to pass the ID anymore. Things will just work behind the scene. Okay, that's one thing to note. I will also write it down. So the parameter list right here does not include. So the list of parameters not including, okay, the ID anymore, which imply no more burden, not a burden of the user of the account constructor anymore. Right? That's a very important thing to note right first. Okay? So if you use a static variable behind the scene, you don't need to force the user to pass you some ID. Okay? And then you will see under the constructor here, we basically try to somehow increment the global counter. Oh, sorry, let me say it again. We try to access its value first and assign its value to the local counter. Step number one. Step number two, we try to increment the global counter, which we kind of know how to trace. And then we try to assign the owner. So these are the three lines. Okay? So the best way to really understand how it will work is to trace some code. Okay? Let's take a look. Okay? So I'm going to trace it just like how we did it last time. But remember, whenever you want to trace a particular class, if you know that there is certain static variable, you want to set aside a storage for that right away. Okay? So what I will do is, right even before tracing these two lines, I would say step number 0, I will set aside some storage for that, right? Step number 0. So I'm going to put a location here for account. It's not really an object, but you can think about just some memory location just for this particular static variable. It's called global counter. I'll just call it GC. Okay? And then I'll put a star here, just my personal convention, just to make sure I know that it's static. And its initial value is simply just 1. Okay? Of course, depending on the application you're building, you can assign any initial value as needed. Okay? So I would say just 1 right here. All right? So that's what I should do first for all the static variable. And then I'm going to trace these two lines. So we are basically creating ACC1 and also ACC2 right here. Right? So these are the two lines we're going to trace carefully. And somehow the IDs for ACC1 and ACC2, they will be guaranteed to be unique and also no duplicates. But let's see exactly how that's going to go. Okay, so let's trace the first one. Okay, so this one here, we are saying ACC1, the reference variable stores the address of an account object right here. Okay, right here. So account. And then now you got to decide what attributes should you include in the box. Right? Remember, only the non-static attributes. So we only got ID and also owner. Okay? So I'm going to put ID here and also owner. Right? So these are the only two. All right, that's good. And then we're going to see, of course, owner is Jim, right? I can put Jim right away, right? Even though Jim is only assigned as a last step, but it's not going to impact. I can just put it right away. It's kind of up to you. But let's now trace these two lines very, very carefully. Okay? Since we are now creating a new object, so we know that the context object is ACC1, right? Let's make a note. It's context objects. So when we actually execute this constructor here for the very first time, every occurrence of this will be replaced by ACC1 and also ACC1. Okay? So what we're doing is, let's say for this assignment here, ACC1.id, ACC1.id, we're changing right here. It should be the current value of the global counter, which is 1. right here. So I should put 1 here. And then the critical step, next one, we say that after this, global counter should be incremented. That means I go to this location here and change it to 2. So this would mean the next object to be created, they are going to be assigned this 2 right here rather than 1. So there's guaranteed there's no duplicates. All right, so that's really the pattern where you're going. Right? Let's now do the second objects. All right, the second one here will be ACC2. So ACC2 stores the address of just another account object right here. Okay, so it's going to be account. And then we got ID and also owner as before. Non-static attributes, ID and also owner. And for convenience, I can put Jeremy right away, right? The last step right here. So I can put Jeremy. And again, let's now say when we execute this constructor here for the second time, the context object right now would be ACC2. So replace every occurrence of this by ACC2. This one here by ACC2. And the similar pattern. So when I try to execute this, ACC2.id, ACC2.id, I'm changing right here. It should be the value for global counter, which has been updated to 2, right? So this one here should be 2. And the next step here is going to update the global counter right here by 1. So change from 2 to 3. That means if I want to create a third account object, it's going to have the ID 3 and etc. So you can see in some way we are managing the ID quite nicely. It's only bounded by how large the max int is, but we don't need to worry for this course, right? Just basically, you can think about conceptually, it's almost unbounded for the ID. All right, so after that, if the most critical line is to really look at acc.getID versus acc2.getID, right? So acc1.getID is going to give you this one here, and acc2.getID will give you 2. And then you can see they are not equal to each other, right? So this one here will be true. So we do have unique ID. And if you want, you can also create as many objects as you like. It's guaranteed the ID will never be duplicated. Of course, there are different ways for you to play with this kind of pattern here. For example, you may change the initial value to be maybe from 1 to 2. So that means you got 2, 3, 4, 5, 6. Or maybe here you got plus plus. Maybe you can say plus equals 2. In that case, you get 1, 3, 5, 7, etc. Right? So you can kind of see what I mean. Another thing I also want to mention to you. So here, for simplicity, we only say that ID here is only just integer value, but you can do even more general. Let's say, for example, if you got a SIM card, like a social insurance number, it does have some string part, right? It's not like a character. It doesn't have just number. So I want to give you a little bit programming tip, right? So you may actually want to introduce maybe another variable in your program. Maybe call that maybe rather than ID, it could be ID string. Okay, I'll write it down. Alternative, right here. Okay, you can declare something called of type string. That's called an ID string. In Java, I'm not too sure if you kind of pick this up from first year, but I'm telling you, it's kind of peculiar. You can somehow say string plus another integer. You can do that. Okay, I'll show it to you, and I'll tell you what it means. I can say maybe I want every ID to have the prefix ID, capital I. I got a string here, I and D. And then concatenate it. So here, the plus here is not addition. It's not arithmetic. So plus the ID right here. So this one here is actually going to give me a string. All right? So if you kind of try this one here, so that means your ID string is going to become something like this. It's going to be ID1 and also ID2, etc. Okay, so that's also something can make your ID a little bit more versatile, right? So it kind of depends on what you need. All right, question? Yes, go ahead.
This condition, so you have to implement speed blocking or other threading blocking mechanisms.
You mean threading?
Threading, does it protect against?
Okay, so I would say we don't really worry about race condition here because we are not really dealing with the concurrency. But you're right, in case we have that kind of concern, you may have to do some like a semaphore or locking, but it's beyond the scope for this course. Okay. All right, all good? Okay. Let's now try to strengthen our understanding. Okay, so this one here is about the correct usage of the static right here. Okay, let's now try to also see the static, but in a different way. I can even tell you that the example I'm going to show to you has some logical error. Okay, that might help you a little bit. Okay, now let's take a look at this. Okay, so let's say we got another class called clients. You can think about a client is a bit like a point collector, which has an array of points, right? Or a person collector, which has an array of persons. And that's the pattern we kind of learned from Lab 0 Part 2, or in the written notes. So a client has an array of accounts. And we also got some integer value number of accounts. From your Lab 0 Part 2, if you recall, there is no static, right? But now I'm adding static keyword to it. So that's the only change I'm trying to introduce right here, right? So now the counter here is static rather than non-static. Everything else stay pretty much the same. So let's say for the add account method here, mutator, I'm going to say whatever you can think, this is really like a this. The accounts array is going to take the value for number of accounts, this counter here, and assign that to ACC, which is something we want to add, and then increment the counter afterwards. So the pattern here is pretty much the same. The only difference is I'm adding static right here. We'll put it another way. The counter now is not going to be local to every client object anymore. The number of accounts counter is going to be global and be shared by all the client objects. Question or insights?
So on the last line in the first part, you wrote this number of accounts.
Yeah.
If you wrote just number of accounts, would that work?
It will also work. So here, good question here. So a little bit similar to what we said last time. This variable here is declared as static. You're only supposed to access it using maybe the class name, like a counter. Sorry, in this case, client, right? If you actually use this, it's not really a compilation error. You might get some warning from the Eclipse. It's going to say you're trying to access a static variable, but you're not really using the class name. So there will be just like a warning.
In this case, though, because it's already in that class, you wouldn't need to.
You wouldn't need to, yeah, exactly. So this is declared as a global variable, let's say within this class over here. So you really don't need this. I put it here just somehow to show to you. Everything stayed the same as what you learned from Lab 0 Part 2, except I just changed this part here by adding static. That's my main intention here, right? All right, guys, I would like you to maybe take a moment, maybe 30 seconds or so. Okay, so now I'm already telling you this code here compiles, but there is a serious logical error. Okay, think about it, and then you guys can maybe share some thoughts if you have any. Let's say if I give you something like this, let's say during the exam or the written test, of course I may not tell you this is an error. I might say this might be okay, in which case you tell me what the output is. Or I might say this is a logical error, explain to me what's wrong, right? So it really depends. So the best way for you to really figure out if there's any error is to write some test cases, like what I did in the green box over there, to really try to create some objects and also try to add them into the account, etc. Try to see if they will work as expected. If they don't really work exactly as expected, then of course you got some logical error. Okay. Okay, go ahead. Any thoughts to share?
We identified the array, but we didn't initialize it with how many elements it has. So we just say private count, and we don't say equals new.
Oh, I see what you mean. So what you're saying here is a valid point. I just didn't show that detail. Okay. So we can assume, let's say, we can assume that when we first created new clients, like a constructor, I didn't even show the constructor here in the class, right? So let's assume we do have this constructor somewhere. It's going to say the accounts equals new accounts array to be some certain length. That's not a concern. Okay, good. Go ahead. Yeah. Yeah, let me just choose your neighbor first. Yeah, go ahead.
We want to see the number of accounts for that client. So now the ID would include the other clients as well.
The ID is also not the issue.
Like the number of accounts variable would be the total of all the clients, which is not true for each client.
You're getting somewhere. Yes. Okay. So somehow what you're saying is somehow this number of counter is shared by all the client objects, right? So if you try to increment it from one client, it's going to be visible by the other client as well, right?
The problem now is that when you're adding things to the array, you're not adding it to the first element in both. You're adding one to the first element and the other to the second. So if you're checking if the first element is this account, it will not be true.
Okay, so you're saying there would be some indexing issue over here. So you may not be storing the object in the consecutive places in the array.
And you're losing on space. Because
You're losing some
you only
space.
have 5. Instead of every account having 5, you only have 5 total. And the index will go
Okay,
after that.
right track, very good. Go ahead, one more, yeah?
I think that each client should have their own amount of accounts, but in this case, they're all sharing the same amount.
So the array here, okay, if I understood correctly, so here the array here is still non-static. So that means every client still have their separate array, right? But it's just that the counter that we use to indexing into the array is really the same counter that's being shared. The array itself is not shared, all right? All right, so hopefully everybody at least put some thoughts into it. Okay, this one here, let's now trace the code. You will see, hopefully as I trace halfway through, you will kind of see what's really wrong. So the way to do it is, let's now trace line by line, okay? First of all, let's create 2 clients objects. So we got Bill, and also we got Steve. And also don't forget, before anything is done, you may want to initialize a static variable first. Okay, so what we have is right here. Let me say stat number 0, okay? And then I'll put stat number 0 right here. So we got one counter for clients. And that one there is the number of accounts initialized to be 0 right here, okay? I'll just say NOA, number of accounts, and it's static. Initialized to be 0. Set it aside, right? Only one copy, okay? That's a really critical point. And then we're gonna create 2 individual client objects. The first one there, so Bill stores the address of one client's objects right here. Clients, okay? And what attribute should we include? We definitely don't include this anymore. Only this one here. That's non-static. So I'll just say ACCS for account. That one there is going to point to some array of certain length. Okay? So let's say index 0, 1, 2. Let me just draw 3 indices, right? And etc. So it'll be 0, 1, and 2. All right? So that's the first client objects. And the second one there is going to be created in a similar way. Let me draw that. Okay. Okay, I'll just copy that over here. And then I'll put it right here. Okay. Okay, let me see. Okay. And then I'll just change that to be green. So you'll see that there are different objects right here. Okay, good. And that one there is Steve. All right, so these are the 2 client objects. As you can see, first of all, the array over here is non-static. So we got one array specifically to this one here, and one array specifically for Steve, right? Non-static. The next 2 lines. So we are saying we are creating ACC1, ACC2, 2 accounts, right? So here I'm just gonna just include the 2 objects here so you can see, right? I don't need to trace any further about how the ID is being created. It's not the point for this tracing here. So I can say ACC1 is pointing to some account objects, right? I'll just put a box, okay? And also we got ACC2, also pointing to another box right here, okay? Just 2 objects, okay? And then we're going to trace about an add account twice. Let's see exactly what's going to happen. Okay? So the very first one here, the context objects for that is Bill. As you can see, Bill is the this, right? So when I execute this method here, you can see ACC1 is the argument, right? So ACC here will be ACC1. So here will be ACC1. And this will be Bill. And there's an implicit this, so it's also bill dot AC accounts. Okay. And of course, this one here is referring to the global storage right here. So let's see what's happening here. Okay. So what we're doing is bill the accounts. So bill the accounts at index 0 right here. It's going to store the address of ACC1. ACC1 is right here, right? So that means it is going to point to right here afterwards. So it's going to point to right here. And afterwards, we say build the number of accounts. It's going to be incremented. So we're going to increment this from 0 to 1. I hope maybe the most of you already see what's wrong here, right? So now you can see the global counter here has now been incremented from 0 to 1. What does that mean? That means for another client object who want to add their very first account, they have to use the counter value being 1 rather than starting from 0. Okay, let's see exactly how this is going to turn out to be. Okay, and then let's now do another one here. We got Steve, the add account right here. Okay, so what we have is the arguments is ACC2. So this part here will be ACC2. And this one here is ACC2. And the context object here is Steve. So here it's going to be Steve dot, and this will be Steve. So we're going to execute the same method for the second time. Right? Let's see exactly what's going to happen here. So we say Steve.accounts. Steve.accounts, this array right here. And then at index 1, right here, is assigned to ACC2. ACC2 is this object here. So that means it's going to point to right here. That's what we're doing, right? So that one there is going to let index 1 pointing to right here. Okay, well, I can draw a little bit better. I'll try not to cross. Index 1 is pointing to this account object here. And then after that, you're also going to increment the counter by another one, from 1 to 2. All right? Apparently, you can see that this space over here is completely skipped and wasted. So as you try to create, try to really add account more and more from different client objects, you can see we'll waste more and more space. I'll show you that. Right? So this one here, you should notice that this one here actually skipped and wasted. Like that. Okay, so that's the logical error. Right? At this point, we don't really have any index out of bound exception, but you might have index of out of bound exception later as you try to skip more and more slots in the array. Okay? One more follow-up for you to think about. Let's say I got another client called Ian. And then let's say add account. And let's say we say add account ACC3. Another question is, if we try to do this one here, how many slots will we have skipped? We'll skip 2, right? Well, obviously, right? So here, what's going to happen is we're going to have the array will look something like this. Okay, right, like that. All right, so we got this 0, 1, 2, etc. And because the current value is actually 2, right here. So that means we're actually going to store at index 2 and let it point to ACC3. That means we actually have wasted and skipped the first 2 slots. They are wasted, right? And the pattern will go on. So you can see just by changing the declaration of the variable here from non-static to static, you can make a huge difference. Okay? All right, question about this one here. We all good? Okay. Go ahead, please.
What happens if we change the variable to a non-static?
You mean this one here?
Yeah.
Okay, good question here. If you get rid of this static here, it's basically your left 0 part 2, which is going to work. In that way, every client object here, like this, is going to have their own copy of NOA. and NOA. That will guarantee it's going to work, right? That's exactly what you will see for your lab 0 part 2, right? So here, there's a very good comparison to see by considering a single variable to be either static or non-static. It might make a logical difference. Most likely, for a particular variable, you cannot really have a working version with that being either static or non-static. It's got to be either one, very likely. Okay. Question, please.
So basically, when we say static, it means that it's accessing the class directly?
Basically, so when you say a variable static, that means there's only a single copy. And you can access this single copy here, simply use the class name. You can say clients, and then the number of accounts. That's what you can do. It is only a single copy. Yeah. Yes?
So what is the intended way for this code to work? Because we know there's a bug and the index isn't correctly working. So if it wasn't a static variable, how would it normally work?
How would it normally work? Okay, so the way it should normally work is, again, back in your lab 0 part 2. So here, let's say this. If we change this to be non-static, okay, like the correct way. In that way, when we first say build the add account, it's going to add to account at index 0. And then when we say Steve.add account, rather than mistakenly going to index 1, it's also going to start from index 0. Right? So the correct way would be whenever you want to add account, it depends on for that particular client objects. It's going to always start from the leftmost free slot of the array. Right? But if you change that to be static, that means the indexing is going to be messed up, really. Good. Yeah, I think it'll be a very nice study for you to really compare this version here and also the correct version that we talked about in Lab 0 Part 2. Okay, question?
Maybe going over the top, but if we get this exact question in the test,
Maybe written test, let's say. Yeah, go ahead.
Well, this code shows the whole public class client thing, and the array is not initialized. I know, like you talked about it, but would we assume that it is initialized or just?
Very good. I think in the actual test, so this is really for the space usage for the in-class demonstration, so I didn't really say that, right? But in the actual test, either I would say it's part of the question, we assume in the constructor, we actually initialize the array. Either I'll say that, or you'll see that explicitly. Yeah. So I think in the actual test, I'll be more careful about the wording, or maybe the information. Okay. All right, guys, any more questions? Good. Okay. One more exercise on the static. Okay, one more. And then we can take a short break. One more. This one here may be something you have seen maybe from the first year, maybe. Okay, but let's see. If no, that's okay. This one here, I can also tell you there's also an error. But this one here is not a logical error. It's more like a compilation error. Okay? So let's now just see what's happening here. So we have a class called bank. Okay? And we got two non-static things. We got one non-static variable. We got one non-static method. Okay? So let's color them. So this one here is non-static. And this one here is also non-static. Meaning that if you want to call either of these, either attribute or method, you must create some bank objects, like a context object to call them. Right? On the other hand, we have this one here is static. And also, this method here is also static. In order to use the pink attributes or pink method, you can say bank dot next account number. Also bank dot get info. You don't need a context object, right? Syntactically, right? That's what we said. And then I can tell you that there's something wrong in either of these two lines, compilation-wise. Okay. Anyone else who want to speak up? I think your fellow student most likely know the answer, right? Okay, go ahead.
The point to access this bench came from a static variable, but in this case you cannot because maybe there is no actual.
Okay, sure. So you're basically saying line number 7 has some error because specifically we are trying to access this thing over here, which is non-static, right? That's pretty much correct, but let's see exactly what's really wrong here. So the compilation error you will get. You can also try to reproduce this, also verify, experiment this a little bit in the Eclipse. you will have some compilation error.
It's not initialized?
Hmm?
It's not initialized?
No, not that. Okay, we'll see. Okay, there's going to be a compilation error. Okay, it's called non-static variable. Variable used in static context. Okay, maybe something you have seen maybe in the first year. If no, now you see it, right? It's also kind of common, right? So that simply means you somehow use a variable in the wrong place. So the non-static variable we are talking about right here is really the branch name. Okay, you can see that one there is non-static, right? So that's the branch name. On the other hand, the static context that we are talking about right here is the method, getInfo. Because that one there, you can see that's declared as static. GetInfo. So Eclipse is going to tell you that there's something wrong. You're trying to use inside the static method a non-static variable. That's the error. But now the question is, why should this be in the error? The answer should be based on very simple principle. You may want to think about how do we usually call a method or attribute that's static. Starting from there, you will be able to see. Anyone? What do you want to try? Huh? This keyword here, it's somehow can tell you potentially there will be some issue from there, yes, but not exactly there. Okay. Anybody? Okay, go ahead, please.
When we call the getInfo function using bank.getInfo, which doesn't have like a context.
Aha. Okay, that's pretty much spot on. Thank you. I'm pretty sure you're thinking the same way. Okay, that's exactly right. Okay, so let's see this. This method here is static. So we know that the expected usage will be, we simply call bank, the class name, dot getInfo. That will be sufficient as far as using this method is concerned. Okay? But the problem is, when you trace to this particular line, this over here must be a context object because branch name is non-static. Can the bank here be used as this? Not really. Bank is a class name. It's not even a context object reference. It's not really. Okay? So you can think about that's really what's wrong. So the bank here is not a context object. It's just a class name. So this would mean when you try to trace down a little bit deeper, when you say bank dot branch name is simply invalid. Right? If you think back, the branch name is non-static, right? This is non-static. And over here, the bank is not an object. Okay, that's really the issue. Okay. Now, the follow-up question, how do we fix this? Right? So there are two possible ways to fix it, but we're going to discuss them. Right? So both fixes will be okay programmatically because you can get rid of the compilation error. But there's a deeper thing you may want to think about. Are they both good design decisions, even though they both work programmatically? Let's see. So I just make two copies of the same code. Let's talk about fix number 1 and fix number 2. Right? So fix number 1, right here, and also fix number 2. Okay, let's see. So for fix number 1, since I know this reference over here is causing me the trouble, I simply just get rid of it. Remove the usage of non-static variable. Okay, I simply make sure every usage of the variable inside the static method is simply static, if there's any. Okay, that's what I do. And in this particular method here, if I say bank.getInfo, it's just going to return back to me maybe the current number of bank objects we have got, right? Something like that, right? Just going to return the value for this global counter, okay? So this means it will just return the value of the global counter. Okay, that's fix number one. In which case, I do not want to modify the branch name declaration. I want to keep it as non-static. Okay, that's fix number one. Question?
So wouldn't, if we do fix one this way, wouldn't it give us a compilation error because we're returning an integer rather than a string?
This one here? Yeah, exactly, yeah. Oh, another, okay, good question here. If you look at the return type, yes. After this fix, we're only returning next account number, which is declared as integer. So integer somehow, okay, I see what you mean. Somehow this integer over here will be, I believe it will be converted into the string. If no, it's a very good observation. Just in case not, just for the illustration purpose, I can just say empty string. That will also work, okay? Good thoughts, okay. I want to be more careful, okay? I can also double check, okay? Anyway, so let's say once we remove this one here, at least it will compile. Maybe if you want to add empty string, it can also work. Okay, fix number two. Somehow, I want to make sure I can still keep this reference here. So what I will do is I'm going to add static right here. So that means we have static string branch name. And this will also make it compile. All right, so we got fix one and fix two. Okay. Which one do you think doesn't make too much reality sense? So the way to think about this is, what does static variable really mean? Right? Go ahead.
I don't think fix 2 makes sense because if you have another branch name, like it's going to be the latest branch name.
Well, yeah, that's good. Okay, that's on the right track. We're thinking this way. Whenever I talk about bank objects, right? Let's say I've got one bank in Mississauga, maybe one bank in North York, maybe one bank in Scarborough. So every local bank should have their own branch name. But now I'm saying every bank object share the same branch name. Conceptually, it doesn't make sense, right? If you see what I mean, right? So that's kind of like a design decision you have to somehow justify or disregard, right? So here, right here, not a good design. Because branch name should be instance specific. Instance specific. Okay, that's really the way to really kind of justify. All right, so we're done with the static variable. Any questions? Yes, go ahead.
Why don't we just remove the static from the method getInfo?
That might be another way to go. Yeah, so that could be another fix number 3. So for example, if you want to remove the static here, that's also fine if you want to. There may be other fixes too. I just want to mention 2 of them. Yeah. Question? Yeah.
In fix one, what happens to branch name if we wanted to return it, but now we can't? What happens?
You mean fix number 2?
No, one.
Fix number 1. If you want to return the branch name, yeah, okay, that's a good question here. Apparently, you cannot put the branch name inside the static, right? In that case, maybe you can create another accessor, which is non-static. Say get branch name, like a getter. That'll be the way to go. Yeah. I think, yeah, we do. Yeah, exactly. Yeah. That's what you have, right? Yeah, okay. All right, so why don't we take a short break by taking attendance, and after that, we'll talk about another topic. Okay. All right, so we're done with the static variable. So let's now talk about how we can use reference aliasing and also the this keyword. So for this one example here, slightly more advanced than the this keyword we talk about when we talk about variable shadowing. So this one will be interesting. Okay, let's see. So I'm going to use a different example here. So let's say we have a person class. Okay, I'll go over the declaration with you. Very simple declaration, but very interesting method you can write. Okay. First of all, let's now take a look at just a person class. Okay. You can see we have a class called person right here. And the person, oh, by the way, there's no static here. So static is not a concern anymore, just non-static. A person has a name, and a person also has a spouse. And the spouse type is also just another person. As you can see, the type of the variable here, just the same as the containing class. Okay, just the same. And this is something just for your knowledge, it's called recursive type. Okay, I'll put a name here. It's called recursive type. The type right here simply refers to the same class itself, but nothing to do with recursion that we're going to learn later in the semester, right? Just the name for the type, okay? And the spouse over here is a reference variable that's going to store some address of another person, right? And in the person constructor, we're going to take their name, and also we only initialize the name. So what does that mean? That means implicitly, the spouse attribute, when you first create a person, the address will be just null. That means the person is single, by default, okay? Not married just yet. And what we want to do is, I can write it down for you. So right here, we're basically saying for the person constructor, okay? So right here, so the spouse is null by default. Okay. So what we want to do is we want to actually have a method mutator called marry. So we may want to marry, for example, Jim to Elsa. Okay, Jim to Elsa, for example. Right? We want to see how we can really implement this method over here. Okay, it might be more complicated than you think, but we're going to work it out exactly. I want to use this example here to show to you, sometimes you don't necessarily have to go for coding right away. You may actually want to go over certain examples over there, and then you want to identify what's really the context objects and what's the arguments, and then from there, you can work out how to implement that in a more general way. Right? That's a good example to really show. Okay, I'll show to you. I'm going to come back to the body of the method, the last step. So step number 1, I want to go over this particular example here. Okay, let's see. So what I have is I have two persons. I got Jim and also I got Elsa. Right? I got two persons, Jim and Elsa. Hopefully I'm not mentioning anybody's name right here. I will change it just in case, right? I don't want to embarrass anybody. So Jim and Elsa. So what we have is we got Jim here, stores the address of a person objects right here. Okay, so I got person, and every person object has the name and spouse, right? Both are non-static. I'll just say name and also spouse. Okay, I'll just say S here. And the name here is going to be just Jim. Okay, I'll put Jim here. And the spouse is going to be null by default. Right, as you can see from here for the constructor. Right, so that's the first objects. And Elsa will be created the similar way. So Elsa over here will be storing the address of another person objects. So here we got person, and then we got the name, and also we got the spouse. The name is going to be different. It's going to be Elsa. And the spouse will be simply just null. Like that. Right? So after these two lines, we have two objects who are not really just married just yet. Okay? And then what we want to do is we want to actually call this method here, which we haven't yet implemented, but you can just conceptually sketch the idea. Right? So let's think about after calling Jim.marry Elsa. Right? At the moment, it should be a legal marriage because both of them are single. Right? Of course, we'll talk about maybe when the proposed marriage can be potentially illegal, then we may have to do output some error. But it's not the case here. So let's keep it simple just for now. So after Jim.marry Elsa, what should really happen conceptually or diagrammatically? The spouse here for Jim should not be here anymore. It should really store the address of Elsa. symmetrically. The Elsa, the spouse over here, should not be null anymore. You should store the address of Jim right here. So it should really point to each other by the spouse attributes, right? So what we have is, number one, Jim.spouse is going to point to Elsa. I'll say that's step number one. Okay. Step number two, symmetrically, Elsa.spouse, rather than storing null, is going to point to Jim. That'll be step number two. Right? So these are the two steps. So this might be your very first sketch about how Jim.Mary is going to work diagrammatically. Okay? And step number two, you may just want to write some Java code specifically for this example here. Okay? So for step number one, what we have is Jim.spouse is assigned Elsa. And step number two, this arrow here, Elsa.spouse is assigned Jim. So also good, right? From the diagram and also in the Java code, right? So hopefully everything kind of makes sense up to now. But the problem is, you cannot simply write these two lines here. You cannot do that. Because if you do that, it's going to tell, Eclipse will tell you Jim doesn't exist. And also Elsa doesn't exist. There's no Jim, there's no Elsa. All we have is this and other. Agree? Whenever you want to program some method in a general way, you can use the this to refer to context objects. In this case, the context object is Jim. And also you can refer to whatever parameter that's being passed to you. In this case, it will be Elsa. Right? So what we should do is let's identify, we kind of reverse engineer about how the method should be implemented. So Jim here is the context objects. And Elsa over here is the parameter, well, argument in this case, but it's really corresponding to the parameter other. Right? Let's now also try to put this correspondence in the two lines. So Jim here is the context object, which is this. And Elsa over here is the parameter, which is other. Similarly, this is other. And Jim over here is this. And notice that what we're doing is the right-hand side of the assignments over here, we're going to put back in the method, is going to refer to just the context object itself, right? So this might be the slight new thing to you if you haven't really programmed this way. Okay? Let's now put it down, okay? And then we'll talk about other things. So we're going to get basically step number one is going to be this dot spouse assign other. Step number two, other dot spouse is assigned this. Right? Again, this is something you want to pay more attention to. So the use of this on the right-hand side of the assignment is also very common in OOP, but you ought to know how to use them. And one way for you to kind of double check, when you try to trace this line right here, Jim is going to replace every occurrence of this. So this will be Jim, and this will be Jim. Elsa is going to replace every occurrence of other. So this will be Elsa, and this will be Elsa. And you compare these two lines, correspond to exactly this example right here. Right? You can check both ways. So these two lines are pretty good. I think definitely on the right track. But now we want to do more robust in the sense that we want to handle illegal situation, right? Let's say. So let's sketch a little bit here. Okay. So what I will do is, okay, let me just draw that. Okay. Let's say we got Jim right here. Let's say Jim is a person, right? We have the name and we have the spouse. Let me just leave the name field empty, okay? So we got spouse. And then we got maybe Elsa. Also a person. And then we got name and we got spouse, right? So far so good, okay? So what we got is Jim the spouse, Elsa. Elsa the spouse, Jim. Okay, all good. So this is actually after we said Jim dot marry Elsa. Exactly these two lines we are executing. Let's say immediately after this one, we said something like Jim, the same person, dot marry Mary. Right? Should this be allowed? Let's say for our context, should not be allowed. Because Jim, at the moment, right here, is already married to somebody else. You should not really let him marry to another person unless you get a divorce first. Maybe we can get another divorce method. Okay, something like that. Okay? So what I'm trying to say is, we want to somehow make the marry method here a little bit more robust by considering two scenarios. Okay? You only try to execute these two lines when it is okay to do so. Otherwise, you really signal some error. That's something I want to also show to you. We want to play with a little bit about logic here. Okay, let's talk about that. Okay, so at this point, specifically, you can see Jim here, not single, right? Just informally, not single. So that means there should be some error. All right. Let's now sketch a little bit. So it sounds like we want to have some conditional, right? To say, if something we do the two steps, otherwise we do something else. And you can think about the something else here. I'll put in common. It's going to be some kind of error. And this will be the kind of next topic starting from Thursday. We're going to see how you can throw exception in Java, right? But for now, let's leave it, just omit it, okay? And this condition right here is going to be some condition we're going to specify. And the condition is going to be, of course, a Boolean, a single Boolean condition. And that one is going to say something like the marriage you're proposing is legal. Yes. Huh? Yeah, something like that. We'll get there, right? So this condition here is about the marriage being legal, right? So what should this be exactly, right? So I'm going to put it aside. They want to suggest something. What should be the single Boolean condition I'm going to write? What should I write? Should be valid Java, right? It's okay. Go ahead. You want to say something? Yeah. I agree. From that example, yes. So from that example, I agree with you. From this particular example here, Jim and Elsa should be, for example, pointing to null in the beginning. That means they're both single. But I simply cannot write Jim is single and Elsa single. There's no Jim and there's no Elsa, right?
Yeah, we could say Jim dot, or like this dot spouse doesn't equal null and other dot spouse.
Okay, both of them should be single, right? So let's say, let me say this dot spouse not equal to null. Oh, sorry, equals null, because not equal to null means married to somebody, right? Beg your pardon, not equal to null. I just wrote the wrong thing. Yeah, exactly. That's also some exercise I'm going to suggest, okay, in a moment, okay? Equals null, that means Jim is, Jim, well, in this case, the context object is single. Other? Other the spouse equals null, okay? We're saying this is single, other is single. But these are two Boolean conditions. So if you want to combine them into a single Boolean condition, apparently we got two choices, right? You can either say %, like an AND, or you can say vertical bar, or. In this case, which one? And, right? Somehow we want to say this is single and other single. Both must be true. If either one of them is not single, then marriage proposed is illegal, right? So it should be %. Okay, so that will be one answer you can write, okay, right here. Okay, I'm going to mention two things over here just for your consideration. Okay, first of all, I want to mention about the operator quickly. Okay, so maybe from your previous math class about discrete math, so what you learned about logic propositional operator. Okay, I'll just mention that quickly. So for math, you got this, you got that, right? Conjunction, disjunction, negation. Okay, conjunction here. Conjunction, and also you can think about informally just and. And also you got disjunction. Or. Also you got negation. These three, okay? Of course you got a programming operator. Okay. Now, I would say roughly equal to, roughly equivalent, not exactly the same. That's something we're going to cover. So you can think about whenever you want to use like an n, you can use n%, approximately. You can use or here, vertical bar, and also explanation mark. And for these two here, we're going to see a little bit later when we talk about the equals method. This is not exactly this. And this is also not exactly this. Because this is more about logic. This is more about programming. I got to explain that a little bit later. Okay? But the essence of it is really about something called short circuit evaluation. Maybe something you heard about, maybe back in the first year. If no, that's okay. We're going to review it when we get there. Okay? It's something called short circuit evaluation, but not at this point. Okay? And what I want you guys to try is consider this exercise, okay, for the Mary method. So exercise here, right here. Okay, let's now try to program the same Mary method. I want to have the same working version, but I want to play with the logic a little bit. Let me just write down the method first. Public, void, Mary. And then we got person here, and then we got other. Right here, okay? So if you recall what we did earlier, we said that we only execute these two steps when the marriage is legal. Otherwise, we print out the error. Can we say the following? We're going to say if the marriage that's proposed is illegal, print out the error. Otherwise, execute those two steps. We're going to really play with the logic, put it opposite way. Okay, already there. I want to say something like, if some condition here is true, I want to print out the error or throw some exception. I'll just say error. Otherwise, I'm going to execute step number 1 and step number 2, the same. Okay? So this condition here is going to be something like the proposed marriage is illegal. So we want to have some idea about how to write this. I'll give you some hints. Okay? Think about here, this condition here talks about being legal. How do you specify the condition being illegal? Right? The easiest way is go like this. If I want to specify something about illegal, it would be simply the negation of being legal. So the simplest way to write is take whatever condition from the legal one and then simply add explanation mark. And then put it here. Okay, that's one way. But I want to dive a little bit deeper. Okay, have you guys heard about something called De Morgan from the math class, right? Let's apply that, right? It's a very practical context to apply. Okay, let's talk about De Morgan. So if I got De Morgan here, if I have negation, right, a little bit like a negation here, and then P and Q, you can think about the P and Q is like P here and Q here. I want to take its negation. Do you guys remember the rule? What's not P and Q? Go ahead.
What
Go ahead. Yeah, yeah. Not P or not Q. Okay. Not P or not Q. Of course, if you want to prove it, you can use a truth table. Right? Let's not worry about it. Okay. Similarly, if I got not P or Q, you'll be equivalent to not P and not Q. Right? Okay. So let's talk about this one here. How do we see this? So you can think about a P here is the one specifies this is single. Or let me put it more explicitly for you. This the spouse equals null. And the Q here is like other dot spouse equals null. And now how do you rewrite it something like a not P? You can just put maybe not like that. Or you can simply say not equal, either way. All right, it's a very almost giving out a solution, but that's okay. I want you to really get yourself convinced about how to rewrite this marry method in different ways, right? Either you put the if condition there being illegal, or the if condition there being legal, right? I might ask you either way in the actual test. Maybe not in the programming test, maybe in the written test. Okay, just make sure you do this exercise here. Okay, I'll let you guys go earlier today, but just bear with me about 1 or 2 minutes, okay? So we're basically done with all the OOP review. So on Thursday, we're gonna start with the exception, like a new lecture, okay? So there are 2 small topics that we haven't got a chance to cover, but you can definitely go over the slides and make sure you go over them for the test, right? So one of them is just about how you can trace like a reference type return value. For example, if you got maybe a method here that returns a point objects, right? So try to do that exercise there. I think there's a little video link just on your slide. You can also go over that video yourself if you want to, but this one should not be too bad to really trace. Okay, that's one thing. And the second thing is just about how to write anonymous objects. Anonymous object simply means it's an object without any name or without its address being stored in a variable. So you can really write something like a new person right here, right? You can see I just simply return a new person expression. That's like objects. Okay, so these 2 things are something we wouldn't really cover explicitly in the class, but that might be covered in the test. Go over them. If you got any trouble understanding these 2 topics, reach out to me or ask the TA. All right, I'll let you go earlier today. Thank you so much. I'll see you tomorrow for the test.